Hi guys, in this video I'm just going to take you through the solutions for the given problems. I am not really going to give out a complete solution, but I'll just give you the thought process, and of course you do the relevant corrections where applicable. So as usual, I said you want to start with a line that is parallel to the x-axis, and you want to see actually what might come out of that, right? So what I've got here, I've got my line, there it is. You can see right through point P where the two lines intersect. And in one of the examples, I showed you that actually we have got vertically opposite angles. And this is a basic concept that you discussed in your grade 8, grade 9 geometry, that whenever two lines intersect, a pair of vertically opposite angles will be established, right? So that's what we've got. So what you've got to think of here is alpha being here as well, actually, because your gradient, you can see for the line AB, you are actually moving in this direction. That is your angle beta for big, and you're gonna have your theta down here, the small one, and you have an equation that says, well, theta plus alpha is equal to beta. Now you know you can find beta, and this is the obtuse case because the gradient here is negative, and you can also find theta. It's an acute case, the gradient is positive. Why am I saying greater? The gradient is positive. So that is basically the idea. Then from here you can see that alpha is actually beta minus theta. That is the thinking process. You've got 2 points for each line, so go for it and find those gradients. In the next one, we had a nice case, and of course, you could continue and use the traditional method that I have shown you, but what I wanted people to do here, or what I hope that you would see, is that actually you can use the interior-exterior angle theorem for this one, because really that is it's quite straightforward. But in any case, let me show both methods, how you'd go about that. So for the first one, of course, here, this again, the first important thing is to note that, well, we've got vertically opposite angles, so that is an alpha. And secondly, we've got an obtuse case here. There is your beta. And of course, you know the equation, the gradient, because you've got 2 points, which are interestingly y-intercept and x-intercept respectively. So it's an obtuse case, m is negative, and then you can now find beta. And now the key thing, or rather a bit of a challenge here is this thing here, but you know you can just do that little trick that I showed you the other day, that this thing is 90. So you can use the fact that this thing is 90 to find angle theta somewhere here. You see, angle theta will be somewhere here. All right. As a matter of fact, without even complicating it further, you can see that this angle here is 90 degrees. Okay. So actually, the entire angle beta, your equation can be even much simpler. The entire angle beta is actually alpha plus 90 degrees, if you look at it. So because this one here is 90, you definitely know that, and there's your alpha, which is vertically opposite to this. Okay, so 90 plus alpha is actually that. So all you've got to do first of all is to find the obtuse case. So your alpha is actually beta minus 90 degrees. Okay, here's the alternative, and this is what I want you to actually get. This thing here is a 90 degrees, and you can simply find this angle, which is going to be the same as that. What is the interesting thing here? Look at this corresponding angles. So the F is there. You can see that angle has got to be equal to that angle. That's another nice way maths is fun and maths is consistent, guys. Just look at that beauty that comes out there. So you could use this, and you could use the fact that, well, this is beta. So again, you can see the equation that I formulated there still comes out. Beta is actually alpha plus 90 degrees. Why? Well, the exterior angle of a triangle is equal to the sum of the opposite interior angles. So you still get the same thing. Alpha is beta minus 90 degrees. Okay, so that's all you had to do there. And finally, the last question, it is essentially the same thing, except that now you are dealing with a positive gradient. So we've got sort of an acute case here. And so let's quickly do this one. I chose the wrong color for the line. So let's go for this. Here it is. And I can just adjust it a little here. So here we are, and we've got our lines that are parallel. So this line is parallel to that. So we know we've got a pair of corresponding angles. So we are looking, we know this one is 90 degrees. We are looking at this angle here. Remember, we measure what? Positive angles, okay? So you just got to find the gradient. Okay, we've got a case where the gradient is positive, greater than 0. Of course, we know then we've got it's an acute case. Maybe I should note that. And so you're going to go ahead and find the gradient, then find this angle. And you know that now, using the fact that the angles are corresponding, that theta is still going to be this theta here. What is interesting then is that you can actually find this angle here, and this angle here is actually vertically opposite to that angle there. Maybe you can call that alpha 1 and this one alpha 2. If you did not see the right angle triangle there and the sum, the interior equals to exterior, right? And the sum of the opposite interior is equals to the exterior. If you did not see that, then you could do this long method. Otherwise, if you saw that and you'd like to do that, this is very easy. This is 90. You are already going to find that angle in an acute case. So again, we can see without any further ado that alpha is actually 90 plus theta, and you are just done finding your angle alpha. So I'm just saying, I actually deliberately gave you this so that you can now start thinking out of the box. I don't want you to be stereotypic. I want you guys to play around with this. And that is the objective of geometry in grade 11. You must be a master of constructions. You must bring some creativity into the math. And hence, I'm showing you this approach of constructing a line parallel to another line. You need to now think of those basic tools that you learned in grade 8 and 9. I hope this is clear, and it is opening up your eyes and really making you to have some fun there during this lockdown. Enjoy, guys.